Dixit. Welcome to the session on Comet Cloud Layered Architecture. So let us begin the session. Learning outcomes. At the end of the session, students will be able to explain Comet Cloud Layered Architecture. They are able to discuss autonomic cloud busting and they are able to explain autonomic cloud bridging. So let us begin the session. Comet Cloud. Comet Cloud is an autonomic computing engine for cloud and grid environments. It is based on the Comet decentralized coordination substrate and supports highly heterogeneous and dynamic cloud and grid infrastructure, integration of a public and private clouds, and autonomic cloud burst. So, Comet Cloud provides a shared coordination space over the Code Overlay Network and various types of programming paradigms such as master, worker, workflow and MapReduce or Hadoop. As well as it supports autonomic cloud burst and autonomic cloud bridging on a virtual cloud which integrates local computational environments and public cloud service on the fly. Also it supports real world scientific and engineering application. So see the diagram, you can see here the architecture, why it is called as layered architecture, because it is divided into layers: programming layer, service layer and infrastructure layer. Programming layer, which is below the application layer, service layer is between programming layer and infrastructure layer, and infrastructure layer which is near to data center or a grid or a cloud. Now we will see in detail what actually happens or what is infrastructure layer. So, infrastructure layer uses the core self-organizing overlay and the squid information discovery, content-based routing substrate built on the top of the core. The routing engine supports flexible content-based routing and complex queuing using partial keywords, wildcards or ranges. It also guarantees that all peer nodes with data elements that match a query or a message will be located. Note that resources in the overlay have different roles and accordingly access privileges based on their credential and capabilities. This layer also provides replication and load balancing services and handles dynamic joins and leaves of nodes as well as node failure. Every node maintains a replica of its successor node's state and reflects changes to this replica whenever its successor notifies it of changes. Now let us move to the service layer. What is service layer? What is a function of service layer? The service layer provides a range of services to support autonomics at the programming and application layer. This layer supports a Lambda-like tuple space coordination model and provides a virtual shared space abstraction as well as associative access primitives. Dynamically constructed transient spaces are also supported to allow applications to explicitly exploit context locality to improve systems performance. Asynchronous messaging and event services are also provided by this layer. And online clustering services support autonomic management and enable self-monitoring control. Event describing the status or behavior of a system component are clustered, and the clustering is used to detect anomalous behavior. Now the last programming layer. The programming layer provides, as the name suggests, the basic framework for application development and management. It supports a range of paradigms including the master worker bot, Masters generate the task and worker consumes them. Masters and workers can communicate via virtual shared space or using a direct connection. Scheduling and monitoring of a task are supported by application framework. The task consistency service is handled means it take care of lost or failed tasks. Even though the replication is provided by the infrastructure layer, a task may be lost due to, for example, network congestion, and in this case there is a no failure. Infrastructure level replication may not be able to handle it, and these cases can be handled by the programming layer. Now let us see what is autonomic cloud busting, which is an important feature. The goal of the autonomic cloud bus is to seamlessly and securely integrate private enterprise cloud and data centers with public utility clouds on demand. What is the purpose of this? To provide the abstraction of resizable computing capability. It enables the dynamic deployment of application component onto a public cloud to address dynamic workload, spikes in demand and other extreme requirements. Look at the diagram, which is space sharing zone, data center, grid, clouds, all are handled in a autonomic cloud busting. So what are the key motivations behind cloud busting? Load dynamics, accuracy of analytics, collaboration of different groups, economics and failures. Now move towards autonomic cloud bridging. We will first see what is autonomic cloud bridging. Autonomic cloud bridging is meant to connect the Comet cloud and a virtual cloud. Consists of public cloud, data center and grid by the dynamic needs of the application. You can look in the diagram also, public cloud, data center and grid. The cloud in the virtual cloud are heterogeneous with different types of resources and cost policies. The performance of each cloud can change over the time by the number of current users. Types of the use clouds, the number of the nodes in each cloud and the resources type of the nodes should be decided according to the changing environment of the clouds and applications resource requirement. The scheduling agent manages autonomic cloud burst over the virtual cloud, and there can be one or more scheduling agents located at a robust, secure master site. If each group requires generating tasks with its own data and managed by the virtual cloud by its own policy, they can have a separate scheduling agent in its master site. The requests for the task generated by the different sites are logged in the Comet Cloud virtual shared space. Spans master nodes at each of the site. Now, what are the policies of autonomic cloud bridging? There are three types of policies: deadline based, budget based and workload based. When the application needs to be completed as soon as possible, we can say that deadline based. When a budget is enforced on the application and a number of workers allocated must ensure that the budget is not violated at that time, budget based. And when the application workload changes, the number of the worker explicitly defined by the application is allocated or released, you can say workload based. Now we will take here in a slide the overview of a Comet cloud based application. Comet Cloud considered three types of cloud base on a perceived security, trust and assign the capabilities accordingly. The first is highly trusted, robust and secure cloud, usually composed of a trusted nodes within an enterprises, which is typically used to host master. The second type of cloud is one composed of a node with such credential that is a cloud of a secure worker. A privileged commode space may span these two clouds. And the third one is the final type of cloud consists of a casual worker. These workers are not part of the space but can access the space through the proxy to obtain the work unit as long as they present required credential. So, overview of a Comet cloud-based application, value at a risk and image registration. So, these are the conclusion. Support core programming paradigm, enables autonomic cloud burst and cloud bridging. Programming system supports deployment of a native application without any change. Current deployment includes virtual cloud integration, Amazon EC2, etc. and incorporate mechanism for fault tolerance to handle node and communication failures and recovery. So, these are the references. Thank you.